Hello guys, good day. So today we're going to discuss about the key concepts of exponential functions. So the performance standard that you should be able to learn is to apply the concepts of inverse function, which is we already been discussed that last meeting, and then exponential functions, which is today, and logarithmic functions to formulate and solve real-life problems with precision and accuracy. So if you already learn about these contents, you should be able to apply these concepts. So today we're going to discuss about the concepts of exponential functions. So one of the objectives that you need to meet today is to distinguish between exponential function, exponential equation, and inequality. So before we proceed to the lesson proper, we should be able to ask these questions in our mind. And after these lessons, you should answer these accurately. So here are the essential questions. First is, what is an exponential function? Second, how do you determine if a function is an exponential or not? And lastly, how do you distinguish between exponential function, exponential equation, and exponential inequality? So let us review what we have been learned about inverse function. We say that an inverse relation or function, it is a relation that performs the opposite operation on x, which is the domain. So if we have these examples, for example, we have original function and inverse function. The original function, let us say f of x is equal to x minus 3. So its inverse function is f raised to negative 1 of x is equal to x plus 1. So as you can see, that the operation of the original function become the opposite, which is from subtraction, and it became addition. Another example is g of x is equal to square root of x, where x should be greater than or equal to 0. So its inverse function is the inverse of g of x is equal to x squared, where x is greater than or equal to 0. As you can see that the opposite of square root is the squared. Another example is h of x is equal to 2x. So its inverse function is the inverse of h of x is equal to 1/2 x. So as you can see that in the original function, the operation is multiplication, which is 2 times x, and its inverse becomes division, which is 1/2 x. It means x divided by 2. And the last example, which is k of x is equal to negative x plus 3. The inverse function of that is k raised to negative 1 of x is equal to negative times x minus 3. So as you can see that the original function, the operation of that is addition, and in the inverse function, it became subtraction. In terms of domain and range of an inverse function, let us remember that the domain of the inverse function is the range of the original function. And of course, the range of the inverse function is the domain of the original function. So let us say if we have the original function in the table form, which is the x values are 20, 30, 50, and 100. And the y values, so each x corresponds to y values. So we have 68, 86, 122, and 212. So the domain of the original function is the set of 20, 30, 50, and 100. And the set of range in this table is the set of 68, 86, 122, and to 212. If we're going to get its inverse, we're going to interchange the domain and range. So the inverse of that table is x is 68, 86, 122, and 212, and the range is, which is y, 20, 30, 50, and 100. As you can see that the domain of the original function is the range of the inverse or its inverse, and the range of the original function is the inverse or is the domain of the inverse relation, or the domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. So let us define the exponential function. So here's the definition. An exponential function can be written in the form of f of x is equal to b raised to x, where b is the base and x is the exponent. And of course, the conditions are the b should be greater than 0. So meaning that the base should not be negative. And of course, should not be equal to 1. Though it says that b is greater than 0, but b should not be equal to 1. So ibig sabihin, hindi pwede yung base natin ay 1. And x is any real number. So here are examples of exponential function. So example number 1, f of x is equal to 3 raised to x. So this is an exponential function because the base is greater than 0 and not equal to 1. And of course, the base is 3 and the exponent contains a variable. Tandaan natin, pag exponential function, yung exponent should be a variable. Another example is f of x is equal to 1/3 raised to x. So the base is 1/3, which is greater than 0. And of course, that is not equal to 1. And the exponent is the variable or is a variable. Another example of exponential function is f of x raised to 2 raised to x plus 1. As you can see that the base is 2, which is it satisfies the condition where b should be greater than 0 but not equal to 1. And of course, the exponent here is x plus 1. It means that it contains a variable. So all of the examples are shown here are examples of exponential functions because it satisfies the condition where the base is greater than 0 but not equal to 1. And of course, the exponent should contain always a variable. So here are some examples that are not exponential functions. So number 1, f of x is equal to x raised to the second power, or f of x is equal to x squared. This is not an example of exponential function because the variable is the base and not the exponent. Tandaan natin, yung variable should be the exponent. Another example of not exponential function is g of x is equal to 1 raised to x. This is not an exponential function because the base is equal to 1 or the base should be greater than 0. Sabi sa condition, the base should not be equal to 1. So in this example, the base is 1, though the exponent contains a variable. But this is not an example of exponential function. Another example of not exponential function is h of x is equal to x raised to x. Why this is not an exponential function? Because both the base and the exponent are variables. Dapat yung variable lang yung exponent, not the base, because it state in the definition that the base should be greater than 0 but not equal to 1. So, anong ibig sabihin? The base should be integers. Integers or positive integers. Hindi pwedeng negative na integers. Positive lang. Kaya sinabi sa condition of the exponential function, the base should be greater than 0. And of course, the base should not be equal to 1. So, earlier, you learned about the definition of exponential function. Let us now proceed to the definition of exponential equation. So, what is it? What's the difference between exponential function and exponential equation? So, let us define exponential equation. When we say exponential equation, it is an equation in which a variable occurs in the exponent. So, ibig sabihin, yung exponent ay variable lagi. At kung exponential equation siya, dapat may equal sign. So, for example, number 1, 2 raised to x is equal to 128. So, this is an exponential equation because it contains an equal sign and of course, the variable occurs in the exponent. Another example is 3 raised to 2 raised to x is equal to 243. This is an example of exponential equation because it contains an equal sign and of course that in the left member of the equation, so the exponent of the variable of the exponent of base 3 contains a variable which is it raised to 2x. Another example is 2 raised to 2x minus 2 is equal to 64. This is an example of an exponential equation because it contains an equal sign and of course the variable occurs in the exponent which is in the left member of the equation. So that is 2x minus 2. So 2x minus 2 is an exponent. Therefore, this exponent contains a variable. Therefore, this example number 3 is an example of exponential equation. Another example is 3 raised to 2x plus 1 is equal to 729. As you can see that this is an exponential equation because a variable occurs in the exponent which is the exponent is 2x plus 1 that contains a variable. Another example is 5 raised to 2x minus 1 is equal to 625. As you can see that the exponent here contains a variable which is 2x minus 1. Another example is 3 raised to 2x which is equal to 243. And this is an example of exponential equation because the exponent in the left member of the equation is 2x which contains a variable. Now, we already know the definition of exponential function and exponential equation. So, exponential function contains function notation which is f of x. The exponential equation contains an equal sign. Of course, the variable occurs in the exponent. So, how about the exponential inequality? So, this is just like the exponential equation, but the difference is the symbol. So, we're going to use the symbol of inequality. And these are greater than, less than, greater than or equal to, or less than or equal to. So let us define. So the definition of exponential equality is that it is an inequality involving exponential expression. So it means that the expression or the inequality should contain an expression where this expression contains the exponent which is a variable. So let us have an examples. So number 1, 25 raised to 2 is greater than or equal to 5 raised to x plus 1. This is an example of an exponential inequality because it contains an inequality symbol which is greater than or equal to. And then, of course, it contains the exponential expression, which is one of the exponents, which is x plus 1, contains a variable. Another example of exponential inequality is 10 raised to x plus 2 is greater than 10,000. As you can see, that the inequality symbol is greater than. So, and the expression 10 raised to x plus 2 is an exponential expression because the exponent contains a variable. And another example of exponential inequality is 1 over 9 raised to 3x plus 5 is less than or equal to 1 over 243 raised to x minus 6. This is an example of exponential inequality because there is an equality symbol which is x which is less than or equal to, and both left and right side of the inequalities, their expression is exponential where their exponents contain variables. So the other one, the left side of the expression, which is 1 over 9 raised to 3x plus 5, its exponent contains a variable. To the right side of this inequality, which is 1 over 243 raised to x minus 6, the exponent is x minus 6, which contains a variable x. Since we already discussed about the difference between the exponential function, exponential equation, and exponential inequality, let us go back to the essential questions that I told you to keep that in your mind, because in this activity, which is activity number 1, you're going to answer these essential questions, which is what is an exponential function? How do you determine if a function is an exponential or not? And how do you distinguish between exponential function, exponential equation, and exponential inequality? So write your answer in the Padlet that I will provide in the TBL Hub.